Good morning, everyone. My name is Michael Peterson.
I'm Lizzie Serrano.
That's better. And I'm Fiona.
We are the deep sea shark research team, and we study the vertical habitat utilization of Cuban dogfish in Exuma Sound. So, commercial fisheries have exploited shallow water fish stocks and are gradually migrating into the deep sea to top off their catch. The graph to the right highlights this point. On the x-axis, it shows time in years, and on the y-axis, it shows mean depth of fishing in meters. And between 1950 and 2000, the mean depth of fishing has rapidly declined from 200 meters to 600 meters. And as a result of this, a number of deep sea shark species have declined also. So due to indiscriminate fishery methods such as trawling and longlining, deep sea sharks are often a result of bycatch. Deep sea sharks are also caught for their squalene, which is an oil found in their liver used for pharmaceutical purposes. And so deep sea sharks are particularly vulnerable to the overpressures of fishing because of their case-selected life history, which means that they are slow growing, slow maturing, and have a small amount of young. And because of this case-selected life history, the population time is very high, which means that the potential for the population to rebound is very low. For example, the lantern shark and the plunket shark are both heavily overfished species and are disappearing before their life history can be studied. And for the population of the lantern shark to double, it would take 58 years, and for the population of the plunket shark to double, it would take 54.
So, what actually is the problem? So, there's little life history data for the behavior characteristics for deep sea sharks. So that means science is basically catching up. So that means deep sea shark species are disappearing faster than we can actually study them. So it's important to study their behavior through space and time. One way of doing this is through satellite telemetry. So satellite telemetry can be used to study a wide variety of species, all the way from birds to fish, but especially in sharks. So this is when a sat tag is placed on a species and it records data spatiotemporally, which means over space and time. So once the tag is placed on a species, it records a full data set to a satellite, which then can be downloaded back to be researched. So one way satellite telemetry has been particularly useful is to study one behavior that deep sea sharks has been seen to exhibit, which is diel vertical migrations. So diel vertical migrations are made by some deep sea shark species, and where diel vertical migrations are vertical movements throughout the water column which are made daily by some species. So this means they occupy depths shallower at night and deeper during the daytime. So this is possibly due to avoidance of predators or due to foraging habits. So as you can see, done in a study by Comfort and Wang in 2014, which highlights the diel vertical migrations of a blunt-nosed six-gill shark, shows that the shark actually went from about 250 meters during the day and then during at night and moved all the way down to almost 650 meters during the day. So even though we have a large amount of data for these deep sea sharks for the larger apex predators such as blunt-nosed six-gill sharks, we are still lacking a lot of life history data for these smaller mesopredators, which are predators that don't occupy the top of the food chain, such as Cuban dogfish. So, Cuban dogfish are a small schooling species specifically found in the western Atlantic Ocean, which range from about the North Carolina all the way down to Argentina, and also found in the Caribbean such as the Bahamas and in the Gulf of Mexico. They range from about a small size, about 39 centimeters, all the way to about 110 centimeters, and are characterized by a small flexible dorsal fin and a small dorsal spine, which you can see right here. As Mikey mentioned earlier, they are also hunted for their squalene, which is a dense oil found in their liver. Because deep-sea fishing efforts have also increased, they are also a victim of bycatch, which is when they're accidentally caught when they're not meant to be caught. So the purpose of our study was to investigate the vertical habitat utilization of Cuban dogfish in the Exuma Sound and to the extent in which they exhibit these diel vertical migrations.
Alright, so our study site was the Exuma Sound, which is a deep water inlet off the Atlantic Ocean. The sound is characterized by rapidly declining slopes, The Sound has previously hosted a study done by Dr. Ed Brooks, which highlights the abundance of deep-sea sharks in this area. The Sound is also a unique location to do this study because it's only 4 miles off the coast of South Eleuthera. So in order to catch the sharks, we set deep-sea long lines, which are about 800 to 1,000 meters deep. They terminated in 30 circle hooks, which are different sizes to catch a variety of different sharks. The lines were soaked in the water for approximately 2.5 hours before they were hauled in using a pot hauler, right here. After that, the sharks were placed in a tote where they are measured and tagged using X tags. The X tags measure light, depth, and temperature every 2 minutes. Sharks are then placed in a release cage, which is a novel idea done by the CEI shark team this fall. The release cage is designed to avoid post-release mortality of the sharks. Here's a video of the cage ascending. As you can see, someone's holding the door open right now, door closed right now, and when it starts ascending, the drag bucket will keep the door open. This is the drag bucket, and it starts saying it'll hold the door open, and when the cage reaches the bottom, the drag bucket will slowly drop and open the door, vaulting the shark out of the cage.
So out of the 6 sharks that we tagged, we got results back from 4 of them. We made sure to only tag sharks that were longer than 60 centimeters because the tags, which are slightly buoyant, could pull the sharks upward and affect our results. All 4 of our sharks were female, 2 were mature and 2 were immature. We made sure to record the satellite tag ID number to make sure we knew which shark was which. The hope is that the tags would stay on the sharks for 14 days, which is the total amount of data that the tags can hold. And for 2 of the sharks, numbers 2 and 3, this was true. But for the 1st and the 4th shark, for whatever reason, the tags came off early and floated up to the surface where once they sensed the constant pressure, began transmitting the data back. This last column shows how much data we actually got back from each of the tags, ranging from 30% to 65%. And the reason that it wasn't 100% because, as Lizzie explained, the way the tags work is they send the data up to a satellite which sends it back down to the database. So anything from a large wave or a cloud covering the sky could affect how much data we get back. So the results show us that Cuban dogfish do in fact perform diavertical migrations. The top parts of the graph are where the sharks were at night, ranging from 200 meters to 600 meters depending on the shark. And the bottom is where they were during the day, between 600 and 1,000 meters. This is a really good example because it's a really clear pattern. At night it's at 200 meters, then at dawn it goes down to 600, and at dusk goes back up to 200. Not all the sharks had those same numbers, but all of them expressed the same pattern. Then we wanted to take things a step further. We came up with 2 terms, migratory scope and thermal gap. Migratory scope is basically the range of the depth that the sharks traveled through, while thermal gap is the range of the temperatures. The way we calculated this for migratory scope was the daily average maximum depth minus daily average minimum depth. And for thermal gap, it was the daily average maximum temperature minus daily average minimum temperature. Then we ran a Kruskal-Wallis test and a post-hoc test to determine which of these sharks were statistically similar. For its migratory scope, the 1st and the 3rd shark were similar, so we labeled them A, while the 2nd and 4th were different, we labeled them B. And for thermal gap, the 1st, 3rd, and 4th sharks were all similar, and so we labeled them A, while the 2nd shark was different, and we labeled it B.
So as mentioned earlier by Tessa, the Cuban dogfish do in fact make diavertical migrations, and these migrations could be associated with foraging and/or predator avoidance. If we compare the maximum depths of the Cuban dogfish in this study to the maximum depths of the blunt-nosed six-gill sharks in Hawaii mentioned earlier, we can see a large amount of niche partitioning. This is when the 2 species partition space, either because of foraging or predator avoidance. For example, the Cuban dogfish might be living deeper at the maximum depths so that they can avoid the predators like blunt-nosed six-gill but still safely forage. So we also noticed large differences in the thermal gap and migratory scope between the individuals in this study. This could be because of partitioning within the species. Some of the sharks' maximum depths range from 600 all the way down to 1,000 meters. We're not positive exactly why, because neither sex, maturity, or size correlated to the depths of the sharks. But although we're not positive why, we still know that they help maintain a healthy ecosystem structure and function through top-down control across multiple ecosystems. Top-down control is when the species is controlling the ecosystem through the top rather than the bottom. And even though the Cuban dogfish aren't the apex predators, meaning that they're not at the very top of the food chain, they're still near the top and they're still helping control the ecosystems. By knowing when and where the sharks are going to be, we can help inform fisheries and set regulations before the sharks are extinct, before we can study them. We'd like to acknowledge Dr. Ed Brooks from Cape Lutheran Institute, Dr. Lance Jordan, Lucy Howie Jordan, Emily Tolentino, all from Microwave Telemetry, and Max Marsh, Microwave Telemetry and the Cape Luther Foundation. Here's our literature cited. Are there any questions?
Did you notice any differences based on weather patterns? Did they stay shallower if it was cloudy or raining outside?
So the question was, do we notice any differences in depth by temperature and weather? So we didn't take into consideration that, and partly because they live so deep that we can't tell how deep they are. We'd have to compare the temperature and weather to that, but they live so deep that they're not getting that much light anyway, so we're not positive, but we don't think that would affect them that much.
Guys, that was a really great job. What follow-up research would you like to see? What did you get to do that you'd like to follow up on now?
So the question was, what further research would we do? And we only ended up getting data back from 4 of the sharks, and so it would be nice to get a wider range, and then maybe we could compare it between the size and the maturity. And we only got female sharks, so we don't really know what the male sharks do. So it'd be really nice to have a larger sample size and see how the data correlates.
Do you have any hypothesis as to why you only got female sharks?
So the question was, do you have any hypothesis as to why we only caught female sharks? Well, Cuban dogfish are actually a small schooling species, so we know that they actually, they're found in a school of sharks that are almost up to 35 species in one school. Possibly we don't know enough about their life history characteristics to tell why we only got females. I mean, there could have been males down there too, but we do not know how they school, or are there many males to one species or one school. So we're not quite sure yet, but it would be a very interesting topic to look at.
And our study is going to help protect these sharks and to conserve them and protect their lives. And so even though those sharks died, we're helping to protect all the other ones.
Do you have other examples of how the Bahamian regulations around deep sea fishing could be informed or you'd like to see influenced by this kind of study or other studies?
Okay, so the question is would we like to see any Bahamian regulations enforced because of this study, correct? Okay, so yes, we actually would like to see deep sea fisheries actually take into account our study, and because they are a victim of bycatch, which is when they are caught accidentally, we'd like to see deep sea fisheries, especially off the coast of the Bahamas, take into account this study. So if we could somehow get them to understand that these sharks move to great depths of over 1,000 meters at some species. During the day, we could make regulations that could possibly say you can only fish at a certain level, like 600 meters, to decrease the amount of mortalities and the amount of bycatch these sharks are victimized by.